Hey guys, welcome to SDTIG. This is part 3 of 4, where we're doing the data science track for Python for Data Camp. And this time we're going to be doing the Python Data Science Toolbox, and then the Statistics Part 1 course, and then a project. Right now you're seeing Dustin's screen, and we're just going to get right into it. So before we talk about the content, did anybody here go to the Spark Summit last week?
Yeah, I
You
did.
did?
Yeah.
Cool. Anybody else?
I dropped in, but
me
I
too, it's
probably
great.
spent a total of 40 minutes there.
Yeah. MC, you did it?
Yep. And Eric was doing stuff, and I think Sean as well.
Sean was, yeah.
That's awesome. How well did it go? What'd you guys think?
I really enjoyed it. Relevant to this conversation, there was the announcement about koalas kind of taking that next leap and being a bigger part of it. So koalas is the pandas APIs on Spark to make it even easier to kind of go from pandas to Spark or just code with pandas in Spark. So that was kind of cool. I didn't spend much time learning more about it, but for people that are getting into pandas and haven't done Spark yet, that'll be a really cool thing.
And so they said that they're going to have a much easier transition. Almost, can you take the same pandas code and just move it over to Spark?
I don't know if they said that. I wouldn't believe that if they did, but it certainly looked like if you import koalas and take pandas code and then start to tweak it to work with Spark, that it wouldn't be, that there is a good path there. And they support pandas UDFs now, which is a pretty slick looking way to do UDF. So I think there's something real there from what I'm seeing. And it seems like there's a big commitment, which is usually the main thing I look for.
So
That's
my
great.
impression of koalas is, hey, we have all of these functions that, if you know SQL, look like, SQL keywords, and you can chain functions as always. But if you're not used to that style of code, if you're used to pandas, then you kind of have to use a different part of your brain, right? So you can intermix the existing SQL-like PySpark functionality with a set of new functions that are more pandas-like. So it's just kind of giving you more options, but it's not pandas. It's just they tried to give you many of the same functions that exist in pandas, but the syntax is not identical. You're not going to be able to just drop your code in.
Well, I like it. I like this conversation because of how often pandas code comes up and has performance problems. And some data scientist or someone, I don't know who, will just create a mountain of pandas code, and then they're just stuck, can't do anything with it. So we were looking at, what was that? I always forget the name of that package from 3 months ago at the DE group.
Dask in order to
Dask,
run
right.
Python
Why do I
code.
remember that? I know Flask. Yeah, Dask. Yeah, I need to work on my memory. So yeah, Dask, that was straight pandas. That they basically said they can
I think
parallelize.
Dask supports more than pandas, but the example that he presented to us was they had pandas, they had things that they knew how to do in pandas, and they just needed to, make it more
Parallelize it.
scalable, run it on a cluster.
And so when they said they had 1 million lines of pandas code, and that's what he said. I don't know if this is true, but he said he had 1 million lines of pandas code, and they ran it over Dask without changing anything, and it worked. Seems like a bold statement.
Yeah, because I think what Dask does behind the scenes is it just basically looks at, I don't know if this is the right terminology, the Python bytecode. And so all it's doing is looking at the atomic operations and then taking that operation graph and trying to run it and to parallelize it as much as possible.
Yeah, it was very Sparky in that it created a DAG that looked very similar to Spark, and it looked, you could see.
Or TensorFlow.
Yeah, or TensorFlow, right? Yeah, it was cool. All right. Any other impressions, you guys, from Spark Summit before we get going?
It was my first time, and with the very small sample size bias, I will say the content looked really good. It was if you wanted to learn things, if you wanted to do programming, and it wasn't just like whatever salesy or whatever stuff. It was good content for actual users. That's my
Awesome.
impression.
Awesome. All right.
I wish I would go to the summit. I know one guy who codes on Spark, and I asked him about Python on Spark, and he told me that actually Python is a wrapper. It's not actual Python as far as I understand. It actually, underneath of it, it runs on Scala. Just my 2 cents, okay? I didn't ask him. I didn't ask him anything more about it.
Yeah, it ends up using the Java and Scala APIs. It uses Java Gateway in order to actually run the code. I don't think I would take that as a slight about Python. There's been times where they don't catch up the Python API to support everything, but they're doing better and better about that in the open source Spark these days. So yeah, it certainly is interacting with the JVM and the Java and Scala APIs that are native to Spark.
But I don't think that means that it's getting transpiled or anything like that. Like the Scala implementation is using the exact same APIs. So it's just either you're using Python to call the APIs or Scala to call the APIs, but it's not like the Scala developers get any type of performance advantage except for maybe 1 or 2 edge cases. There's a little bit of a performance advantage, but for the most part, it's the same experience. And
most
then
teams were using Scala from what I saw based on their presentations, and every benchmark I've seen does show Scala pretty much ahead of Python, but they've done a lot of optimizations in Spark 3 that was just released, so I don't know when we're going to see a whole lot of benchmarks, seeing if the playing field has been leveled completely. Microsoft's also working on a .NET API library for Spark as well, so that'll be interesting. And they're still plugging away at that.
They released it. It's released. I don't think that it's
I checked like last week, and it still said that it was in pre-release on a 0.12.
Oh, really? I thought they were trying to release it for last week.
I was hoping it would, and I did not. I looked, and it was still pre-release like last week.
So Azure Synapse has .NET kind of ready to go and built into it. Whatever version of the open source or special branch they have, I'm not sure. And that's still in public preview though anyway. So if it's not like fully V1, that wouldn't be too shocking, but it's supposed to work pretty well within the Azure Synapse environment at least. I haven't tried it in any other environments.
Hey, Matt, when you said there was a performance difference between Python and Scala, are you talking about like data frame code? Because yeah, I was under the impression that you're calling the exact same data frame APIs, whether you write it in R, Python, Scala. And so the performance ought to be identical.
Well, it's not identical from every benchmark I've seen. If you look at the .NET website, they even have one porting showing their performance compared to PySpark and to native Scala Spark, and Scala is definitely ahead, and .NET on the ones that they were able to run is a little bit faster than Python, but it's not like, we're talking about 10 to 20% faster, probably not something to worry about too much. There is, marshalling that has to go back and forth between the Python and the Java virtual machine and stuff like that.
Oh, that's interesting. Yeah, I'm seeing this on the Microsoft site. That's interesting.
Go ahead and paste it into the chat, Ike.
Yeah, sure. The only thing I'll say is like, what I've heard commonly is that it's the Scala function issue that makes Scala faster than Python, that the Python functions don't get to run inside the Spark memory address space on the workers.
Yeah,
So
you're
they
just
have,
talking about the UDFs, right?
yeah, the
Yeah.
UDFs call out.
And now that's changed significantly in Spark 3 because of Apache Arrow and some other optimizations they were able to do with zero memory copy between the two processes. So it'd be interesting to see where it's at now.
Yeah, I would not be as hesitant to use UDFs in Python as I used to be once we're on 3.0 on all the projects, but certainly there's differences. I mean, I'm not trying to say that Python and Spark run Scala, or sorry, Python and Scala are the exact same, but yeah, it's leveraging a lot of the same APIs and calls, and it's still leveraging the JVM. So it's not something that I shy away from. Whereas for a while, I think we were a little worried about performance of PySpark. I don't have that viewpoint anymore. I really just, if it's the best tool for the team to write in, that's what I would go with. There's certainly some libraries that are only in Scala. That's usually add-on libraries, not so much the core APIs, except for a few things that I've seen. I'm sure there's a few others out there.
Interesting. All right, well, shall we dig into the content? I don't want to turn this into a Spark class, but that was a fun conversation. I liked it. Yeah, let's dig in.
Cool, and hopefully I did enough of this that we have the answers showing up. So if we start with, well, there's the video about user-defined functions and pandas. Whoops, wrong button. Okay. Yeah, so I'll kind of just walk through and expect lots of chiming in here. So they talk a bit about strings in Python and give us a little quiz about how they work.
Yeah, that was no big deal.
Yeah, I think there's another quiz that's pretty easy to get the right answer on.
Yep.
A simple function. So if we do, just make sure we call out in case there's anyone that hasn't done this yet. So here's the function syntax: def, function name, can pass parameters here. And this one's very simple. It's basically a hello world type function.
Yep.
Is this, has anybody gone through in order? Because I sort of skipped to this one. Did anyone go through in order? Is this the first time that functions were covered?
Well,
in
yeah,
this
I don't know.
course, yes. Yeah.
So I'll sort of say yes, but just know that the different modules were not created as a whole. They're sort of standalone. So stuff does get repeated and whatever.
Right. That's kind of what I was asking. I've seen the repetition already, so I was wondering if this is a repetition of previous things because, or if this is like the very first time that people have seen it.
I don't remember defining functions before here.
I didn't learn anything in this section, so I don't know. I can't remember if they covered it anywhere else.
Yeah, and the modules we covered in this group, they weren't used before this. And so, yeah, Data Science Toolbox, I think we're expecting some of the other things, but they started us here. And it is important to know if you're brand new to Python, but it's also a fairly easy thing to pick up on, I think.
It is weird that they start with a function with a side effect immediately. Like we can't cover a basic function with return. I don't know.
Well, you know what they say about Python, right? It's a language for when you can't decide whether to use object, procedural, or functional all within the same module.
Yeah, yeah.
I can say that about a lot of languages though now these days. I think, JavaScript, Scala, like even that is very a jumble of those things, right? I think all languages are evolving because we recognize that some, functional is great in some cases, object-oriented is great in some cases. You kind of need little bits of this and that, to get the job done quicker.
It's the same thing that's happening in the database space where the SQL Server has all these NoSQL features now, And all the, NoSQL stores are like, oh, you can tune the consistency levels and you can have ACID compliance if you do these 5 things. And you're like, well, apparently we don't need, why even distinguish these things as NoSQL or SQL? Like, we're just going to bleed into each other forever and make the market really confused.
Yeah, I always think of, the state now, especially with so much adoption of cloud, that we use a lot of different systems and tools for a single, system. We don't try and do everything in one platform anymore. Yet, I agree. A lot of the tools are trying to be everything to everyone.
Yeah. Yeah. So the C# has a whole bunch of dynamic features, and they have, supposedly functional C#, right? That people try to code like that.
The interesting thing coming to C# in my mind from a functional aspect is C# 9 will have the immutable record types.
That is interesting. I wonder if they did that because of the Spark implementation requirements.
Well, I'm sure it was on, the hit list for a while for a lot of functional paradigms or whatever require sort of immutability, or would be better with immutability or with immutable enforcements, I guess. So I think it was on the list to try and do for a while. It's just that they finally decided it was, so maybe it was Spark that pushed them toward it, but it has been on the roadmap.
A couple of these C# 9 features do look very Python-y to me, like how they're initting the properties. They're trying to make writing the code easier without types, it looks like. Yeah, there's like some type inference going on, which doesn't seem very static to me.
It is, though.
Oh, okay, sorry.
Even dynamic is like you're statically typing this thing to be dynamic.
Yeah.
It's weird.
Yeah.
Okay,
all right.
ready to keep going?
Yeah.
Back to Python.
Yeah.
So we have a single parameter function. So now we have passed a parameter in. Amazing stuff here.
Yeah.
We return a value in this one, which I did not do. I think we'll see it in a second anyway, though. Let's just make sure. So we actually return a value instead of print it, which I was referring to as avoid the side effect, return something and set it to a variable, and then do your thing with it here.
So is this can you go back a little bit?
Yeah.
What you were talking about, MC, where you're like, hey, let's just mess object-oriented and functional and procedural all in one language. Like, is this a common theme where they call a function in the same module that they defined like this, like in the script?
Yes. Yeah. If you get data scientists, I mean this with all respect, if you get data scientists writing functions in a Python module and then leveraging it within the same module, that's a huge step. And I'm glad they're teaching this in a data science track versus just write one big sequential script and let it go wild.
Oh.
Which sounds crazy, I'm sure, to some of you, but I've seen that and seen really good, useful code that way. Yeah, getting all the way to classes is it's a step that doesn't necessarily need to happen in Python to write code that's way better than we would otherwise.
Okay.
Waiting for someone to boo my statement. No one cares. Cool.
No, I agree. In fact, the module in Python is, you can have state in a module, right? And that's something that C# doesn't have. Everything has to be within a class, right? Whereas in Python, a module can have state. You can have variables that are quote unquote global to this file, right? To this group of code. And that's state, that's what you might choose to use a class as in other languages, right? So I agree.
And I like that it makes you think, do I really benefit from having a class for this versus always having that boilerplate for very small things.
Yep.
Ready?
Yes.
All right. So next we talk about multiple parameters and return values. Man, I could have sworn I did this. I didn't have a premium account at the time, I think. So maybe I just didn't save it properly or lost it. So for multiple parameters, and then we leverage them and return a value and print it. Any thoughts on this one?
Looks the same to me, just multiple
Yeah,
param
I don't think
arguments.
it gets interesting until like the named values or whatever, right? Okay, I mean tuples
I
is
mean,
awesome.
this is neat though.
Tuples, if we haven't done, I don't know if we did this one as a group yet. So tuples, if you have a tuple such as nums here, you can unpack it just by setting the right number of variables on the left side of equals.
Yeah.
Yeah,
Yeah, I think
that's
that's
a
cool.
neat thing to know.
And now that's possible. I mean, like to you know, the point earlier, that's possible in so many languages now, but it wasn't possible in very many languages like 2 years ago, right? But JavaScript has it now, and C# has it, and you know, it's everywhere. But I think, you know, prior to 2 years ago, that was kind of a rarity.
Yeah, I find that is just incredibly convenient. Sometimes you're like, I've got a thing, and then you're like, oh, now I have two things. Well, guess what? Just like, you can just put a comma between them for the most part and like, you know, move on with life and not have to think too hard about it. Sometimes it's just really convenient.
I agree.
That's cool.
Yeah, every once in a while, I think you need to do something like this where you actually return a tuple instead of, you know, a single variable or some kind of object if it's a more complex example. So I have the example on line 11 of how you actually build a tuple. You just put a few things together inside of parentheses and you have a tuple. Pretty easy. Then we bring it all together. What's that mean here? Do we want, I don't know, any questions on this one? So we're back to using pandas. We're reading tweets from a file, which is funny. Usually this is an example where you're streaming, but so be it. We got a file of tweets. That's pretty exciting. We do some looping. I felt like this was more of a reminder of, hey, we're still doing pandas, even though we just spent a bunch of time on functions. I'm not sure what stood out to anyone on this one.
I don't remember. Did they just take this same functionality and then turn it into a function on the next page?
Yeah, my guess is they do. Can you run it?
Yeah, see how it says bring it all together one? I think you're going to do, then you're going to do the exact same functionality, but now we're going to introduce some functions.
I just caught this. They tell you the goal halfway through their 4 paragraphs. It says, we're just trying to get you to recall how to load stuff into a data frame.
All right.
All right, so now we remember. And we get to another one I didn't do, I guess.
So you take the data frame.
Yeah, we're taking a data frame into a function. Oh, yeah, okay. We might be getting to something exciting here. They actually do quite a bit in this function. It's been a little bit since I did this, so I don't remember a lot about the scenario here. We're just kind of grabbing some.
They're counting the
miscellaneous stuff
number
about
of
tweets.
languages that are in the CSV file.
Yeah, I think that for people newer to programming, they're just trying to demonstrate the concept of, see, we did this thing. You did it. You wrote code. We're now going to encapsulate this in a function. So you could reuse it. You don't have to just copy and paste the code every time you want to redo this.
Yeah.
I
think that was the goal of those two.
Sorry, Hugo's tried to talk. I don't know if you guys can hear my computer sound. Hopefully not.
No.
Okay, then I didn't need to stop it so fast. But. All right, so that was pretty much it. The last thing was the congrats. And then, yeah, any other thoughts on chapter 1?
No.
Kind of a good get started.
Basic stuff, yeah.
Basic stuff, yeah.
All right, now we start talking about scope and user-defined functions, which are really just functions. I don't know why they keep calling them those. So pop quiz, this is probably actually a little bit tricky. They're actually using the global call here, which I've used once or twice, and every time I'm kind of wondering if I should be doing it personally.
Probably not.
Yeah, probably not.
If you need something from global, just ask for the argument. Tell them to pass in the value. Now it's standalone. Like, I
Yeah.
don't understand why global's valuable.
Yeah, but basically if I define a variable within a function, it is scoped to that function. So it's got pretty narrow local scope in that case. And if I
When I
define it
used
with
to teach beginning programming classes, scope always kind of threw people off for some reason. I never really understood why. I had to always tread very carefully around scope and when things leave memory, and I don't know.
I'll say anytime I'm doing something with scope that's not normal to do, usually it's not as clean of a design. Then I get a little bit, wait, what's happening? Anytime there's globals that are coming from somewhere, I'm like, wait, what's going on? But the typical case is pretty straightforward once you get the hang of it, I guess.
Wait, what do you think, Scott? You think this global keyword is a good thing for the language or a bad thing?
Well, remember that there are multiple purposes to Python, right? There's, people writing good production code with it, and there's also, I just need to get some stuff done, right? And I want to get it done quickly. So the global and there's another one. What is it? Enclosing or what is it?
The local one, yeah.
Non-local,
Non-local,
yeah. Yeah, so those two are just like hacks so that you can get something done quickly, but there's always a better way to do it. It may take you more time, right?
Yeah.
So I agree. It's for the script kiddie, side of Python, right?
I do recall it being useful in a couple cases where I didn't know when you were doing some like passing functions around within a function. There were some useful effects of having locals and globals and stuff like that, I think.
Mm.
I mean, in my opinion, there's always a way around it that's sort of like better programming style, but it all depends on what your goal is. Are you writing production code, or are you just trying to find out an answer and you're going to throw away the code anyway? If you're trying to find out an answer, just type the word global and be done with it, right? It's only if you're like trying to write maintainable code that you don't really want to use it.
Yeah. Okay, let's go to the next one.
Okay. So they talk a little more about global. I think we've probably talked about that one enough. They start talking about built-ins, which is interesting. I think, Scott, I think you actually walked through some different like built-ins by example on the first meeting we did.
Yeah, there's a lot of them. And yeah, we had that talk about how do you know whether it's a built-in function or not, like unless you've memorized the list of built-ins, right? It's a huge part of Python, and it's not intuitive. It's not obvious unless you just know them, right? Yeah, look at that.
I think I might
not
have
even-
started that conversation because I was saying how I hate the built-ins because
Yeah.
I'm doing object dot this, object dot that, and then all of a sudden somebody says, no, you have to say print paren or del paren. It's like, wait, I just got so used to doing object dot whatever.
Yeah. Yeah.
My experience was the opposite. I was using built-ins all over the place, and then all of a sudden I'm like, wait, this is a method of a string. I don't really think of it as an object when I'm working with Python.
Yeah, I think it's fair to come at it from either direction. It's just
the
little bit of I don't know what you want to call it, just a brain traffic jam if you have to do both of them.
There's a schism. There's a schism in the language.
I would have said cognitive dissonance, but I was trying to keep it simple.
All right.
Very important.
So now we're going to get into nested functions. Again, something I don't do very often. Usually by this point, I'm starting to build a class if needed.
So these I do use. Well, I mean, so there's a lot of things in Python that sort of require nested functions, and one of those is decorators. So you've probably seen the @ sign on, you know, some Python code somewhere, and that thing is a decorator. And to write a decorator, you have to have a nested function, a function that returns another function, right? So that's one place that they're used all over the place, like they're sort of required. So I'm glad they covered them here.
Yeah, I think basically, building out a partial function I've seen a little more. This is an interesting example though, a tuple of function calls. Okay. Now we're going deeper into nested functions. They actually mention the idea of a closure here. Anyone wants to describe that for us?
That's just a function that knows about state outside of its function. And the way it works is something other than a function is actually created underneath the covers, right? Something that actually has the state. Yeah. Anyway.
Okay.
So where is it trying to explain that in this?
They mention right here.
Okay.
But then they don't really use the state. They don't really use an example.
They use a variable from the outer function, but
they don't really do anything with the state it knows about.
oh no, there we go. Right.
They use n ike, which is state from the enclosing function.
State from the enclosing function.
All right.
I mean, it's not a local variable, but it's a parameter, so it's state from the enclosing function.
Are you ready?
Yeah.
Yep.
So if I could just make a side comment, I mean, I think this is cool, and I'm like a dinosaur enough that like this was not available in, you know, plain C or, you know, Fortran, Pascal, any of the languages that, you know, when I first learned programming. So I have to like think a little bit. It does not occur to me that a beginning data scientist needs to know closures. I mean, that to me seems completely avoidable. Maybe it'll take you 10 more lines of code, but completely avoidable.
It's kind of like when you click on a link to like a blog post that's talking about doing something for data science, and you realize they really just put data science in there to get you to click on it. That's kind of what some of this one feels like. It's not bad to know, but yeah, it's a little off track to me.
I mean, I don't think you actually even need to know that it is a closure. And I think most people, like, because of the way it's nested, it's intuitive that you can have access to the outer variable, right? It's like, oh yeah, I'm still inside of that section that knows about that variable, so of course it has access to it, right? Without thinking to themselves, wait, but that's function, and I did pass it in as a parameter, so how the heck does it know about it, right? But I think, you know, because it's so intuitive, and it's as Ted says, you know, it's not that common, it is a little weird to bring it up here, you know. But
and then non-local,
I think it's intuitive for you, Scott, and I'm happy for you.
No,
I don't think it's intuitive.
No. I think it's intuitive, period. Like if you go back one, Dustin, right to that in. Of course, look, I have access to the in. I now have access to the in. It's scoped, right? Everything inside has access to stuff outside, right? Like imagine in another language, those are curly braces there, right? Like you can sub the word def with like if. Of course you have access to the in, right? Pretend that pretend that def on line 7
Yeah.
says if, right? Then you wouldn't think twice about having access to that in.
The issue isn't whether or not you have access to n. The issue is when you change n, does inner echo change or not? And that I don't think is just completely obvious.
Does this example show whether it does or not?
Yeah, I think they call twice and thrice, right?
No, but that's not changing the state. That's just calling it, see line 8, that's just multiplying word. The twice and thrice aren't in the function, aren't in the outer function. That's what I thought. That would be a more interesting example, is if the outer function was calling the inner function and preserving state in between.
So that was the question I had. What's the answer to that? Does it change if you change n later on?
If you just like concatenate a couple of calls, like if you say on line 10.
No, they do. So look, so he says twice is a function in closure. I don't know what the closure, the right name is. It's a partial function with 2 as its state, and thrice is a closure with 3 as its partial state. And then at the bottom line in the print, they call those closures with the same exact parameter, hello, but you get different outputs from twice and thrice.
Yeah, but in is not being modified.
Yeah, in's not being modified in the repeated calls.
And that's where the confusion comes in.
Yeah.
So I'm talking.
Okay, so it's an input parameter. So there, but you could have just as easily had n be a local variable, right? I mean, you could have just said pass 2 in as x and then say n equals x.
Yeah. Yes.
But I'm just saying, like a construct like this.
Does the modification? I mean, I guess I need more specifics around the question in terms of does the modification.
Dustin?
Yes.
On line 10, can you create a variable called test equals inner echo underscore word 1?
Yeah.
And indent that. Yeah.
The function name?
No. You're right. No.
Password one. Okay.
Yep. That. Or let's just put inner echo and type in, whatever word in a string. Sorry, not. There we go. Yeah, just some string. There we go. One ike is enough. Now indent that. Now
the echo. Okay.
Copy that line and do it again. And just concatenate. Just plus equal or whatever.
Yeah.
Okay. Now
return test.
Just run the code and see what happens.
We're not doing anything with tests.
You're not using tests, so.
Oh, return test. Yeah, return test. Yep.
So we're not doing anything with n at this point.
So does in? So inner
here?
echo word and what? Yeah, we are doing something with n. If you look at the twice and thrice, we're handing 2 and 3 in, and so I was hoping we would see twice as many ikes as we expect to see. What's this error that str object is not callable?
Yeah, because you see, you're returning test, which is a string now, instead of what I think you want to do is put this code above the declaration of the inner echo, and then pass in test instead of n, or something like that.
Did this show what you wanted?
Oh, I see.
Not really. It's the same result, right?
Yeah, I was trying to see how the call would work, but now that I map it out of my head.
So Bridget, you can use the key when you take apart your. All right, I can do it later.
Every time I click the button, it goes beep, 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 and then unlocks.
It's okay.
Oh, that's usually if a door is.
It isn't mapping in my
We
head.
can
the way I
hear you,
thought it would.
Ted. Just a heads up.
It just keeps
Are we good, or do you want to
Yeah,
keep
we're
on
good.
through
We're
this?
good.
Okay.
No, we're good.
All right.
That's like the problem I had with my car.
I
Do you want me to mute Ted?
Probably.
Okay.
Okay. Now you can unmute him.
I'm
Oh,
so
see-
sorry. I turned off the video. I forgot to mute the audio.
If
That's
I ever
okay.
do that, I want you to mute me for the record. So that's why I said mute him. All right. So non-local and nested functions. Do you want to keep moving? See if we can get to another section tonight.
Oh yeah. Yep.
Definitely stop me, but I'll kind of move a little for faster through this piece. So default
keep-
and
keep
flexible
going.
arguments. This is worth chatting about probably. Let's see how good this example is. I did more of this. I don't know why it didn't save it. So here's a default argument in Python. It's probably fairly intuitive, but just set it equals to in the function definition.
And then basically, if you pass it, it gets the value it was passed. But if you don't, it gets that value of 1. Right. So
Right, which I think they're proving out in the exercises. You can have multiple default parameters. Now we're getting interesting. Who wants to talk about args?
So args are like they're from C, right? That's where they first came in. Where in printf, and then a bunch of languages pick that up so that you can pass any number of arguments to this function, and you basically just get an array inside of the function with the things that you passed.
Right, so here's the great example of the call where you're just passing a whole bunch of names, not as a list, but as different parameters to gibberish. Gets interpreted as an args list or array, loop through it, build up this hodgepodge word, and return it back out. Pretty simple, but yeah, args is pretty powerful.
Sorry.
What's up?
I was just saying, I meant list. I said array, but I meant list.
Okay.
Yeah, and I would say that this actually can come up if you're trying to write clean, sort of extensible code, where basically you're going to have additional arguments that you don't know about, and you're just going to pass them on. So rather than having to explicitly know about all the things that you might pass on later, you can simply say, I can take an arbitrary 0 or more length thing, and then I'm going to typically, pass it in as extra parameters to some other call.
Yeah, args and keyword args I actually learned from a data scientist. So I'll give that props for being something I see in data science, maybe more than, I guess everything I do is kind of on the realm of data science, but yeah, I see that a lot. So I think it's a good one to call out. Okay. So now we have keyword args. Let me get this example up for us. Did it do it? Yeah, it's interesting code. So in this one, you're basically getting a dictionary instead of a list, and they're looping through the key and value pair. There we go. There's the important stuff. So here we're making up name value pairs as parameters, which is a little bit different. Do they show the way? Well, there's another way we tend to use this that I can't remember if they show, where we tend to build up basically a Python dictionary and then kind of unpack that. Or basically just pass the dictionary in, and that's where I see this used the most, is when you want to just build up a dictionary like a config, send it into a function that then knows how to handle it.
Oh, so you know what? I actually spoke too soon. So this is actually the way you use it with function arguments.
Yeah.
Both mean, I would say you get them in both situations, right? So you can use when the values are all like the you have and
You're kind of cutting out, Scott.
booleans and all kinds of other things going in. Okay, I'll just stop.
Well, I don't mean to have you stop, but I don't know, is there a place with better reception?
I was trying to catch enough to piece it back together, but I don't think I did.
Yeah.
It's cutting in and out here, and it's just, you know, welcome to the boonies.
Yeah. All right. You want to keep going?
Keep on moving.
Yeah, keep on moving.
So then we bring it all together. Probably won't spend too much time on this. They just kind of go through a longer example using some default arguments, I guess. I didn't even see it when I was scrolling through. Yeah, default argument of language, and they might call it with both to prove it out. Okay. And then another example. All right, same type of thing. I think they're using the star args one there. Lambda functions. I know this is Matt's favorite thing.
Really, MC?
They're cool, I guess.
Your favorite? It's very C#, huh?
So basically the idea here is that we can define a function anonymously, and I don't think this is the best example of why you would use it. Let's see if they give us a good one here.
I love doing it in line with map, filter, and reduce functionality.
Yeah, they show that in a little bit.
Do they? All right, let's jump forward to that, I think.
Yeah,
here we
right
go.
here.
Okay, so this is where you might do it. Who wants to talk us through this? Line 5 here.
Well, you have a list of spells, which I guess are probably Harry Potter spells. And then you have a map function that defines a function that takes one argument called item. And then after the colon, it acts on that argument. So in this case, if you hand in the word protego into the Lambda, it will add 3 exclamation marks to the end of protego. And so what the map function does is the first argument is the Lambda function, the anonymous function that adds exclamation marks. And the second argument is the list of strings. And so what map does is it submits everything in your list into the Lambda. So it will apply that exclamation mark logic to every word in the list, and then it will it'll spit it out into shout spells, which is another list, but that list shout spells will have the exclamation marks.
Great. So yeah, so you can see the output of the Lambda, the map with the Lambda is that it took each item and added those 3 exclamation points. In case it's helpful for anyone, I think it may not be, but this is basically, if you didn't want to do a Lambda, you would basically create a function that takes in an item, returns a value, and you could pass in the function itself instead of creating the Lambda inline.
Yeah,
which might be useful if it's...
Move line 9 up. And so that's, you can see the, didn't, yeah, okay. And so there, you know, you can see it does save you a little bit of typing. And what I always heard back in the day when I was teaching this was it improves the visual locality of reference. In other words, you can see what it's doing where you need to see what it's doing.
But
Like
the thing it doesn't do, I think,
so-
very well is allow for complicated functions, right? because the
Oh
lambdas
yeah,
will be
yeah.
too
If
hard
you have a
to read.
complicated function, get it out of a lambda. Absolutely. Yeah, get it out
But
of there if it's.
And in
I
Scala, I
don't-
use these a lot. In Python, because of this extra, basically because of this extra lambda word that I don't like to deal with, I don't use it as much. However, you wouldn't want to have a whole bunch of different variations of two-line functions all over the place. I agree that if it's that simple, which this is pretty simple, doing them in line in a map or one of those types of operators is
It's
that is
convenient
better in
for
those
Panda
cases.
supply.
For Panda supply.
Yes.
Yeah, I think that sounds right to me. Yeah, you would just apply and throw the function in on the fly rather than having to define it separately.
Yeah, so apply would go on every row versus map on, list items.
Right.
Yeah,
We did.
and
I think we did that in the last pandas section. I think they showed that.
We did apply. I doubt that we used a lambda with it though, right? So if you take those same examples and use lambda, that'd be a pretty realistic scenario as well as this map here.
yeah, and I was going to say, for me, a simple good rule of thumb is if you can't fit the function on that one line of your editor, then you shouldn't be creating a lambda. Just go ahead and actually write it out as a real function.
You agree
I
with that,
have
Scott?
that same rule of thumb. Couldn't agree more.
.NET would like a word with you.
Who would?
C# would like a word with you.
Yeah.
I do not see that followed in Scala either, and it's got its pros and cons.
Yeah, and I mean, I can see the argument for if you're really only going to ever use it once, you're never going to use it again, right? Sort of the sort of the classic definition of a function is it's reusable, right? So I kind of get that, but I do find that oftentimes sort of the syntax, you gain the locality, but sometimes you also gain like a bunch of parentheses and things, and like it's not always very readable.
That's a rule that I
Lots of
obey in
sense.
Python, but I don't obey it in C#. In C#, you'll have like, I'm trying to think. Oh, remember the parallel for each and stuff like that, where it would take in a delegate and that delegate basically represented the body of your for loop. So that was one case where you almost had to have a mini line, as lambda. But in general, I would say, keep it small.
Okay. We see what other examples they give us. So they do a filter with a lambda. I think that's a pretty good example, in my opinion, of how to take a list and cleanly filter it down based on pretty simple logic.
Wait, I have a question on this.
Good.
Hold up. Can you replace that whole thing with Sterlin? So from lambda over to len member. Keep going, keep going, keep going. Okay, right there. Can you say str.len? Or is it, yeah, I think that's right. Or is it? No parens. Run. No, dang it. Is it length? Maybe length? Doesn't it have, I think it has, stir has a, nope, no parens still though. Yeah. Doesn't it have a length function? Dang it, maybe it does.
Oh, I think that's one of those built-in things, Scott.
I think
Did
it's
that do
a
it?
dunder method.
I think that did the same
Count?
thing. I was trying to figure out what it's
I
actually
know it
filtering
is,
on,
but
though.
I thought that it also had, yeah.
Did I like,
Point.
this seems like it's not working right though.
Yeah, what it was trying to do is greater than 6.
Is it supposed to there it
Yeah.
is, okay.
That was what it was supposed to be, greater than 6, yeah.
All right, cool.
Yeah.
Yeah.
So your len was effectively just returning true.
Yeah. Okay. All right, next.
Yeah.
Reduce. You want to look at this one?
I mean, it makes sense. There's times when you really want to do reduce on something. You might do like a max kind of a reduce. And I would say, even if there are other ways you can do it, you will probably see this type of code if you're reading sample code. So it seems to me a legitimate thing to explain to someone learning.
Yeah. Like, I think, is this going to work for us? No, I don't know. Yeah, okay. Any other comments on reduce before we move on?
Nope.
All right. Error handling, very good thing to know. That's basically just testing if you can figure out what type of error it returns. But here's basically the try except format of Python error handling. And a lot of times you would do things like except key error, or some specific type of error, and then you can always do as something to reference it, which is pretty similar to other languages in my experience. So in this case, they just basically trigger it to print out if it's an error, and so we can see it notice the error, catch the error, and print it out.
Okay.
Comments? Yeah.
Nope. Pretty standard SEH.
You can raise, this is not using error handling to raise the error, they're raising their own error. So this is why sometimes you may raise an error if something looks off, so that the calling function can catch it and do something with it, I think is the point of that.
That's basically the other side of the coin, right? So
Yeah.
catching, and then on the other side, throwing or raising the exception.
Yep.
Do any of you guys know how to raise your own custom errors, like inside of a try? Like basically, if I say, hey, I'm going to try this and I know I'm going to get some really weird error, I just want to replace that with my nice, pretty.
You just put the raise in the, in the accept.
So you could do something like this, and then you would need to do.
You need to define my exception, which is a class.
Oh.
I think you would do that.
Yep.
Now I forget if you have to put the
colon pass. Wait, just say colon.
Yeah, colon pass or
And-
colon doc string, I think will resolve it too.
Yeah.
But it's not raising it,
Yeah.
is it? Something like that, Ted, even though it didn't call it.
Yeah, because I wasn't doing it with the class. I just did it with like a string, and then what ended up happening is I got my exception that I raised, but it was concatenated with the original exception, and so it was like, okay, you got the pretty error message, but it was after 65 lines of gobbledygook, the original exception.
Interesting. Were you doing this on Pandas or Python core? In Spark, it definitely gets interesting because you have Java and everything happening under the covers.
It's just
Python.
It's just Jupyter Notebook.
The other thing you can do if you just want to get something out the door is just use the base exception, but typically you want to give it a better message than, or give it a more clear exception type than that.
Mm-hmm. Okay, thanks.
Most of the conversations I have are, let's just raise the exception or let's wrap it in raise and not do anything about it, because usually there's like one piece in the whole thing that's going to handle it and do something important with it, and the rest of it's just trying to catch them and give us something useful. I don't know if that's typical, but for like building libraries, in Python, we typically let it flow upstream and just kind of deal with it at the top.
Yeah, no, I mean, this was an unusual use case. Basically, I was trying to walk people through setting up their system to have all the files in the right place. And so basically it was like, if it didn't find the files in the right place, it was going to yell, right? But I didn't want the actual error, because it wasn't about that we were trying to load the file or that we were whatever. It was just trying to tell them, do I see all the files in the right place? And how it was doing it was by trying to actually read the files in.
Gotcha.
So in theory, it would have been fine if they just saw like the file not found error or whatever,
Yeah.
right? But I was just trying to replace that with a little friendlier thing saying something's wrong, not all the files are in the right place.
Yeah. So here's another example. I think is similar to what we did in that one exercise I went through quick, where we're using a built-in error type and just passing a custom message with it. A pretty common way to raise those. Ready to move on?
Yes.
Think error handling skills. Go test those if you want to. And congratulations. I think that's the whole, the whole module.
Yeepa.
So where to next? Are we going straight to?
Stats. This is exciting. We're going to have Ted teach us.
What just happened? I did the wrong thing.
Yeah, go back. Yeah.
You went into practice instead
Yeah,
of
you
the
gotta go to
original lesson.
start.
If you ever
Yeah.
need someone to user test your web page who's not going to read anything, they're just going to click the brightest button there.
Yeah.
I'm your guy. I do not take the time to read this stuff.
Go back to 5 in progress. I think you can click on 5 in
Well, I'm
progress.
done is the problem.
Oh,
Yeah,
then
so click on data scientist Python track, and it's just
and just scroll through it. Yeah.
That yellow, yeah.
And then you gotta actually click show all, because it's only going to show you the first 4 or 5 courses.
Which is annoying.
And
Yep.
then if you scroll down, you'll find your statistical one.
Yeah, this is how I do it pretty much every time. And for some reason, when I'm sharing my screen, I try to do it a better way, and I find out I don't know how. I skipped it too. Wait. Oh, come on. Just take me there. I don't have to replay the course, right? I can look at like. All right.
You can just
What am I missing?
go into the whatchamacallit, the table of contents, and just start going through it.
Do you see where it is though? That's what I'm struggling with. I'm used to seeing something different.
Yeah, scroll down. Is it there?
Prereqs,
Keep
course.
going,
Oh, there
keep
we go.
going. There it is.
Thank you. Yeah. All right. Sorry about that. Thanks for hanging in there. So, introduction about exploratory data analysis. It is detective work, apparently. Basically, visualize the data, poke around, try and get some ideas about it before you go into modeling or statistical like findings. Histograms are popular things in EDA, and then we use Seaborn. Did we use Seaborn as any other modules we did before?
No, we didn't.
But we skipped. Remember, this is now
one.
pretty far
Yeah.
down. So they actually had 2 or 3 Matplotlib and I think 2 Seaborn courses.
Yeah.
What I liked was how little I needed to know about Seaborn to just use it in this course. I was kind of like, okay, SNS.set, and we just kind of kept using PyPlot for everything.
I like Seaborn, incidentally. I didn't do the Seaborn class, but I do agree that their visuals are very attractive, like compared to some of the other visuals I've seen. I really like how they render.
So this is your beautiful
and if
Seaborn.
anybody else doesn't like them, instead of SNS set with empty parameters, you can actually pick from like 25 different styles. So you can, there's one of them that's actually like Matplotlib original, And so if you're using one of the new Seaborn functions, but you want it to look like Matplotlib, right? And there's one for ggplot, and there's one for Plotly. And so if you actually really like the style of some other package, you can feel at home with Seaborn.
And I like that they use the iris data set. So it's kind of like if you're not already sick of this data set that everyone used for machine learning, you will be sick of it by the time you're done with this chapter. So made sure that we get our fill. After doing a pretty interesting video with voting data that I thought was pretty interesting, they send us to the iris data.
Yeah.
All right, ready to move on? See some more?
Yeah, histograms are
There's
standard.
histogram. Let's take a look at.
He said this in the lectures a lot. Always label your stuff.
Label your stuff every time. Yep. And plt.show is the magic command once you've set everything up.
Yeah.
And we're basically just passing a NumPy array, aren't we? Or is this a full-on?
I thought it was
You can use the
pandas, but I'm not
shell.
sure.
Use the shell. Just copy it and paste it.
Yeah. Do like type, yeah, array.
Just a regular array? Yeah, NumPy array. Okay.
Yeah.
So just call that out. That later we'll use data frames. We start off with just an array, so it's pretty simple. Here we are messing with the number of bins, and they make it very elaborate, but ultimately there's a parameter called bins that we can pass into. It's pretty much all that was added, with plus some calculations that I assume are to teach us some good practices or something.
Yeah, the squirt of the length of the array, I guess. Interesting.
B-swarm plots. Let me run one if anyone feels up for talking about it, whether you like it or not.
Well, I liked what he taught about it in the video, which was that basically the binning is biased. And if you want to see all of your values and the distribution, that a B-swarm plot is a better way of doing that. So I agree that the binning is biased because I have changed the bins to be biased to the point I was trying to make. So, you know, I do like it. I think it might be a little bit harder to read, but the questions that he asks, I don't know if he asked them in this one or later, but he's like, hey, which flower has smaller petals? Yes, you can clearly answer that. Which flowers have a wider varying lengths? Yes, you can clearly answer that. Do the versicolor species and the virginica overlap in petal size? Yes, they do overlap, but the other two don't overlap in their size, right? So yeah, I think if you're trying to answer those questions related to distribution without hiding any values, this is a good way to do it. But I just had, you know, if you haven't seen this before, I just taught you how to read it. It seems like with histograms, there's a lot less teaching. Like people just look at it and they're like, okay, I can interpret this. I know what it is. Where in this visual, somebody needs to train you how to read this so that you understand what you're measuring against.
Agree. That's what I didn't like, is it felt like there was some type of x-axis happening, but there really isn't. These are just all the same number, and it just tries to show you that it's a
wider number that are at
right,
that
as the
value,
count.
right?
Yeah.
Yeah, I mean, I think they could
You're cutting out, Scott.
introducing these plots, you know, in elementary school or something, and then they would become standard and easily readable.
Yeah, that's true. That's true. Okay, you want to keep going?
Okay. So bee swarms, if I remember right, we did quite a bit of these. All right, so we're
Yeah,
answering
that's the
questions. I think I
interpreting it.
ran us through these already, how well these answer a few questions, or one question in that
Now
case.
this is where I was like, I have no idea what's going on here. So
Yes.
I don't know if Ted wants to teach us what's happening here, but I didn't really fully think that I understood it enough to ever use it in the wild.
So I think by the way, I got to like this point and only just a little bit past this. But I believe in the video where he introduces these, what he says is that the limitation of the bee swarm plot is going to be if you get past, 100, 200, whatever, some number, you're not going to be able to see the dots.
It bleeds, yeah, and it hides the
Right.
values, right?
Yeah, so there's the example, right? It's too many things, the dots just look gross, right? And in theory, right, sometimes you see some charts where instead of dots they actually have like pictures of cars, and so you see like 2.5 cars, and that's pretty intuitive. You don't need to be told how to read it, right? But the dots, they have to jitter them in order to get them to not overlap and stuff, and so that's where it breaks down. So the distribution function, you could have a million things, and basically it's just like if you know your percentiles, it's basically just mapping out your percentiles.
Yes. It's mapping out your percentiles. So like this right here, like percent of vote for Obama to 100, and then ECOF, that which is the empirical cumulative distribution function. Like
if you just replace ECDF with percentile, I think then you'd know how to read this chart.
So 60, so no, I don't think I do, Ted. So 75% of counties had less than half a vote for Obama. So,
So this is your
that makes
75th
sense.
percentile, right? And then
That
you
makes
just
sense,
trace
yeah.
it down to see what your X is telling you about your 75th percentile.
So that means that 25% of the counties had more than half the vote.
So the
and then what does this one outlier right here at the top, Ted? What does that one tell me?
That's just your 99th, your 100th percentile.
Oh, that's so 100% had less than 80% of the vote. Is that what you're saying?
Yeah, so no county voted more than whatever that number is, 80-ish. Yeah.
Oh, okay,
for Obama,
okay.
Right.
So even what county had only 20% of the vote for Obama? What county was that? Is it like a county where he killed somebody or something? Like 3 counties were down here in the 20? I don't even, this can't be California.
There's one dot way over there on the left that's below 10%.
Yeah.
Yeah.
And so
what's going on over there?
Later he looks at population, and I think it was population, it was something like population, and that was a huge factor in kind of knowing where they're going to fall. So this may be a pretty small town that has their problems with Obama.
But so in this case, right, it's the number of counties. It's not the number of people in the county. I think I got to the point where
it's
he
the number of
switched to
counties.
population.
I had to stop and go, wait, how does this make any sense? And then I kind of, it forced me to look more closely at what he was counting based on, what this shows. So it was effective in letting me see that, wait, that's not where I thought that breaking point would be based on the results of the total election, right?
Yeah, so if you imagine a histogram with really skinny bins, okay, to the point where basically you eventually turned it into just a continuous function, okay, then what this is basically just sort of the integral from left to right. It's the total area, and eventually it's going to always hit 1. It's always going to hit 100% of the area.
Right.
So I don't know if that helps. I don't know if the percentile thing
I think
helps.
it does help. I think it does help. I think I need to think about it a little more, but yeah. Okay, we can move on.
Let's go. Because there's one where they start getting into percentiles. Let me just try and run each one so we can kind of see if there's anything anyone wants to call out. Oh, that's just code. That's no fun.
Yeah, they actually have code that's called like calculate the percentiles.
Yeah, that's kind of what I was trying to get to. So we built this ECDF function if you missed it. And it's basically trying to figure out how to evenly spread this data over a 0 to 1 x-axis, right? More or less.
Yep.
And it has to be sorted for it to work right. We do some basic, I believe, plotting of that. That looks kind of similar to what we just saw. We're looking at our petal length here. And
by the way, if you well, okay, we can sort of look at this one, but if you look at the green dots, I don't know if you've ever seen like a normal distribution kind of looks like a bell-shaped curve, right?
Yep.
That's the amount of things at any particular value. But if you did the cumulative of things less than or equal to a particular value, then you kind of get this S-shaped
That makes sense.
function, right? So I do believe that these petals are somewhat normally distributed, and so that's why these
Have a similar shape.
yeah. So if you were looking at just the histogram, you might, or again with teeny tiny bins, a cumulative version of it, you might see a bell curve, and then with this you see this is just sort of the cumulative, the area from left to right, so to speak.
Okay, that makes sense.
okay, cool. I knew I needed Ted to talk about this.
Yeah, it actually does really well, Ted. Thank you.
Well, and actually, I know Maya's on, and so she's probably got way more math background than me. So feel free to jump in at any point.
Yeah, Maya. Okay, so mean and median, which everyone learned in 5th grade, I think.
An outlier can significantly affect.
Although
both.
when I was watching this part, I did think of a new insult where I'm tired of everyone on Facebook misinterpreting COVID data. And I thought that I'll never do it, but I thought I would comment next time. I've got one friend in particular, like, I can't believe I'm taking health advice from somebody who doesn't know the difference between mean and median. But anyway, it seems like everybody's a statistical expert now on Facebook is my point.
All right.
On a COVID note, I had a friend say, like, I don't know what the big deal is. I don't think we're going to have more than 0.05% deaths in the United States. That's what they said. I think we're only going to see 0.05% deaths. What's the big deal? Like, you're talking about hundreds of thousands of people. Like, anyway.
I'm trying to do the math in my head. Haven't we already broken that?
Yeah, we might have. I don't know. Let's see. What is it? 350 million people here?
Is that like 150,000? We're not quite there, but we're getting really close.
Yeah. Yeah. Hang on.
All right.
Yeah, 175,000 is what that is.
Oh, there we go.
Yeah.
And where are we at? We're below that still?
I think we're at 110, but the projections are we'll hit that this year. Yeah.
Yeah, I think unfortunately we're about 125 now, but
oh my God.
Depends on how, I don't remember when I last looked.
Okay, so yeah, let's keep going.
Yeah, okay. Nothing too special here. We're doing NumPy mean to get the mean of a array. Cool.
Although it is neat that NumPy, just takes a bunch of values and tells you the mean real quick, like very, very Excel-like.
And this one we'll see the code in a moment. The percentiles, I thought, oh, that's pretty neat. I hadn't thought about that. But here's where you set up an array of the different percentiles you want. So 25th percentile, 50th, so on. And then you can call NumPy percentile with an array and the percentiles you chose. And you get out a bunch of numbers, but basically it's
all categorized into your percentile.
Either one, yeah.
I'll just comment again that this may seem like an artificial example, but the reality is I've done this like countless times where somebody starts by saying, hey, what's the mean and the median? You're like, oh, that's interesting. What's the 75th percentile? What's the 90th? oh, what's the 80th? Well, what's the 85th? And after a little while, you're like, how about I just make a little list of the different percentiles you want?
Yeah.
I'm going to write this exact code. And then you can see like the different ones side by side.
So
And
when
then-
people start asking me that question, I just throw the data. So maybe I should be more Python-y when I do that. But typically what I do is just grab the results, throw it in Excel, and ask for the statistical summary. It's an Excel add-in, and it will tell you mean, median. You could type in the percentile that you want. It tells it to you. It will tell you the standard deviation. It will tell you so many things about the data. And it's just like one little Excel button.
But if you want to make the data scientist big bucks, do it in Python.
Yeah, that's right. That's right.
That or just, LS on your downloads folder on your screen and go do it all in Excel on the
Yeah.
side.
Yeah.
Okay, so percentiles, pretty handy.
Yep.
Then we do wait, what are we doing this time? Okay, now this is what I was thinking about earlier, Ike. So here they throw a diamond on each percentile, so you can.
That does
Kinda be
make it
nice
a
if they
lot
had a label
more
too.
readable if
Yeah.
you're basically getting the benefit of the histogram and the ECDF, because by dictating the diamond, you're binning. You're effectively setting the marks that you care about.
Okay. And the code for that got just slightly different, but it's mostly just specifying some properties in the plot, parameters in the plot.
Yeah, then that box and whisker plot, which it is true that a lot of decision makers have never seen a box plot before, but then once you teach it to them, it's all they want to see. Every single decision maker I've shown a box plot to in Power BI, they're just like, now they want it all the time.
Does anybody here, I'm not going to call out individual names, but does anybody here know the precise definition of the length of the, I don't even know what it's called. Is it a whisker? I don't know.
So I think it's the 0.75.
I mean, it's a multiple of the interquartile range, but it's like, I don't know.
I'm pretty sure it was in the slides, unless I ended
It
up
is
in
in the
help
slides.
documentation. So it
He
was in the
definitely
slides.
describes it in his lecture.
And I thought, oh, I don't need to memorize this. No one's going to ask me that in the meetup.
Well, the thing is, I always feel like I can go and I can look up the definition, but then when I just read the word for word definition, I can't reconcile to exactly how to compute that length. Like why is the one on the right, why is the bar below the green short, but the bar above the green long?
So this here, the bottom of the box is 25th percentile. Is that correct? Yeah. So then what is
Yes.
this? I don't think is it 2.5 or is it something different? Oh.
So right, so the line's the median, and the top and the bottom of the box are the 25th, 75th percentiles. But the whiskers or whatever are like some multiple interquartile range, and I've never quite figured out the exact way you compute that. It sounds all nice, and then when I look at it, I'm like, oh wait, I can't actually really.
You mean with like numbers? You're
Well, so
we
for
lost you in the middle of the
working
joke.
it out by hand?
No, so for example, can you explain why on the green, the bar below is not the same size, the same length as the bar above?
Doesn't that just mean there are more values above it? Not more values. Sorry. A wider, what is it? Yeah. I see what you're saying now, but can you go to the slide stuff?
I don't see it in the slides. Let me see if I can get that on. Oh, it opened it in preview. Hang on.
What bar do you mean? Horizontal, vertical?
Yeah, so I'm talking about the little vertical bars. I don't know if they're called whiskers or what, but basically you have your median, your 25th, your 75th percentile in the box. And then you have the lines that extend from it. And I know that they're calculated based on the interquartile range, but I don't actually know how exactly you calculate the length of that line that extends above and below the box.
I don't think it's in the slides. I thought he said it though. Anyway.
All right, I'll Google it and I'll
let us
answer
know.
myself. But it's one of those things where, like, you know, I have a lot of these moments where, you know, I think I understand something and then someone asks a really basic question, you know, along the lines of like, why is the sky blue? You know, like, why is that line so long?
Nope. Okay. Yes, get back to us with the answer. I don't know. I thought I'd seen it as part of this though. So we get into variance and standard deviation. Any comments on this? If I remember right, we like do some things more by hand and then we can just call it. Yeah, we can just print the standard deviation by doing this, right?
Yeah,
Maybe
you can't
not.
highlight it. Yeah, you
Yeah.
can't highlight it.
So we kind of do it a slightly harder way and then we just call standard deviation. So just showing us kind of the spread of the data.
Would you say this course is enough to understand statistics? Or
Probably not. I mean, if
Oh.
you don't understand central tendency and you don't understand distribution.
yeah.
That may have been in the stuff we skipped, though.
Yeah, could have been, I guess.
Well, and there's a whole part two that I didn't go through all the stuff in there.
That's true.
So at least to start though, we start talking about Pearson correlation, which I will not attempt to say what that is, but if someone else wants to describe it for us. Scatter plot. Beautiful. Go ahead.
Yeah, those are, scatter plots are useful.
Yeah, I'm surprised I didn't start with scatter plot, though we might have done those when we were like first getting started. Any comments on this one? This was not my strong suit, this little question here. So we can see the variance by how spread out things are.
Well,
Yeah.
I didn't know what I was doing here, but I'll tell you how I figured it out, right? So the highest variance in variable X, right? So I looked at the answers and they were only comparing A and D. And so to me, it looked like D had more variance in the values because it looked like somebody like dropped an egg from a high height and it just splattered. So I'm like, okay, that looks like there's a lot of variance. Then it said the highest covariance, it was asking between C and D. And to me, because the covariance was moving off like a Gartner quadrant, I'm like, well, that looked like C has more covariance. And then a negative covariance, they're asking between B and A. And because it looked like the covariance was going up to the right, then a negative covariance to me seems like it should be going to the up to the left. So I answered B. So that's how I figured out it was DCB. I'm not sure. I don't know what I'm doing, but
You should be teaching SAT prep courses.
Yeah, that's why I kept taking multiple choice testing. So like A and D don't have a significant covariance, right?
Yeah.
It's not
Yes, because it's spread out too much. C has the smallest covariance, well, the closest to one covariance because it is almost along the line. And covariance checks how our points are distributed along the line. So B, they're more or less along the line. And we see, well, not much. Positive and negative, they mean positive and negative slope of the line. When line is
positive negative slope of the line. Yeah.
Yes.
That makes sense.
Should I explain it? Or you know?
No, it makes sense to me.
So then Maya, is it like if high covariance is if X is going up, Y is going up?
High covariance is, sorry, I missed
Yes.
it, when it goes
Yes.
from lower left angle corner to the upper
So
They go up together, they go down
right
together.
angle.
briefly, we
Yes,
looked at
exactly.
correlation. So in this case, the covariance between X and Y is just the correlation between X and Y.
Yeah. Yeah.
Yes, and the smallest value of correlation is -1, and then we again have points which are situated almost along the line, but it goes from upper left corner to the lower right corner.
Yeah. Yeah.
Yeah, and just to be clear, in order to have high correlation, the slope doesn't have to be the 45-degree angle. It could be any slope.
Yeah. Anything that looks like it's marching up the hill. Yeah.
Line is what Maya said. That's super high correlation.
Yeah. Yeah.
And well,
But-
when
but-
it is
but- but
close
it-
to zero, it is considered as a low correlation.
Right. Right. All right.
Great.
Yeah. Thank you.
So now we compute it with, sorry, it's kind of collapsing everything here. We compute it with mp.cov. Pretty
Yeah.
cool. Oh, maybe not. Something like that. I think I highlighted again. I was trying to see, yeah, so it's printing out. This is kind of interesting, the printout to me, but oh no, it wasn't that. It was the matrix I found kind of interesting. I don't know if I got my head around that yet, but I know how to find what I need, so I'm good. Pearson correlation or correlation coefficient. Any comments or thoughts on this one?
This is where I started getting lost.
I didn't like it that it is a matrix. And then you need to pick up one of the values of the matrix. I think it would be simpler if they would do just the value, one value, which we usually just need one value. That's it from the matrix. But I guess they wanted to do it to work for several random variables.
Yeah, I'm afraid I didn't get to this part, so I don't know how strongly it was explained or whatever.
Okay.
Well, it returns a matrix. A matrix is when the first element in the upper left corner, it is correlation of X with itself, so it is just 1. And then we move to the next value to the right. It will be correlation X and Y. Then we have a second row, and the first entry in the row is again correlation between X and Y, and then the second is correlation between Y and Y itself, so it should be 1.
Yeah, you can see Dustin just printed it. It's symmetric.
So
Yeah.
this will always be 1. Is that what I'm understanding?
Yes, on the main
Yeah.
diagonal, you always have 1.
Okay, you're saying how much is X correlated with X, how much is X correlated with Y, or how much is Y correlated with Y? Yeah, so it's kind of funny that, anyway.
You
I found it kind of
probably-
weird that they didn't just give us a function that gave us back.
You probably can put several vectors in there,
Yeah,
and then you get a bigger matrix. Then
that makes sense.
it is computed correlation between each vector.
So why did they give us one that was, why is this one symmetrical?
Well, Dustin
Because-
printed that out. That wasn't part of the original exercise. And if It's always going to be symmetrical when you call it like this.
Because correlation between x and y is the same as correlation between y and x. It doesn't matter in which order you compute the correlation.
Right, it's commutative.
Oh, I see. I see. Okay, that makes sense.
I was going to try throwing another one in there, but I don't know if one's available, so we won't get lost in that. Anything else on this one, on this exercise? Okay. Probabilistic logic and statistical inference. Let's see here. So we kind of get into generating data sets in order to do this, right? And so we start using NumPy random, which is similar or the same to Python random. I think the structure is about the same. It's probably just working on arrays more than the normal random class would.
Yeah, it's probably just faster for large arrays. Yeah.
Did they not import this? There we go. I didn't really follow the point of this one, and to be honest, I don't think I read this section over here.
I
Good.
think they're trying to prove it's a uniform distribution, so it doesn't look like a bell. It looks like a flat line.
Okay. I think we start using it pretty soon here. I am not going to explain Bernoulli trials. Do we want to take the time to have someone explain that?
I didn't get here. Are they just building a binomial distribution?
I think they call something binomial distribution soon, and I'm trying to remember if it's the same thing. It's a flip. It's basically like flip of a coin style things, except there's a probability you can include in it. I guess I can run the code and see. I think this
Right,
just.
but what are they
outputs
doing? Are they
something.
graphing it or?
We will, I'm pretty sure. This is just kind of building up the function, I guess. So then we start to use that Bernoulli trials to get back a whole bunch of results. And then I think we plot out, yeah, we kind of set a threshold of the number of defaults out of 100 loans in each trial, if I remember right. Did my thing break? I thought it would just plot something for us. Okay.
You were highlighted. Yeah.
All right. Should we keep moving through this pretty quick so we can look at the project too? Yeah.
Yeah.
All right. So we pull back our ECDF function, do some more things, end up with a nice ECDF. So basically just starting to put together a lot of those pieces. And then, yeah, we get into this. So they actually have a binomial call. Yeah, so it's basically instead of custom writing it,
Highlight.
we can use one that's already built. If I would have known that, I would have skipped all the other stuff, but so be it. All right, I'm going to keep moving because oh, there we go. Okay. Stop me if you want to talk about any of this before we move on.
The problem is I don't understand statistics well enough to like talk about why this is cool or why it isn't cool.
Yeah.
I almost feel like, I don't know.
Well, as somebody who computed everything by hand at some point, I love it.
You love it. Yeah, as somebody who's done it by hand, right?
Yeah, or using tables.
Yeah, I guess it gets that through and it tries to explain the reason for them. And I do think some of it was repetitive, but as I went through it, I was getting a better idea of it, but not enough that I want to describe it to a group of people.
Well, since Ted didn't do this and we were relying on him too. No, just kidding, Ted. Do we want to move on to the project, or
Do
we've got a couple of choices, which is let's move
It's
on.
already 7:15. So let's
Dustin,
we're
do you
supposed
mind
to
just clicking on the course outline and just seeing what else is
move
in
on,
the
I'd say. Yeah.
continuous variables.
Yeah, we're pretty much there. We get into continuous variables. It actually shows, here's what I think, I don't know if we need to come back to this point, but there was something about
doing exploratory data analysis.
maybe not. There we go. So they actually show you, hey, here's what a normal distribution looks like, and talk about that.
Yeah, the bell
Yeah.
curve.
Okay. So to the project, I think is what I heard.
Yeah.
Okay.
Yeah, that sounds good.
Did anyone not complete it that can share the screen?
Oh yeah, you need to go to projects
Yeah.
and search it by name. I don't know
Oh,
why
it wasn't
you have to do
even
that.
like you couldn't even get to it from there, right? I had to go
Yes.
find it out here.
Yeah.
Yes.
The
with
only
the
way.
Python one, yeah.
Okay. Oh, you know what? I've got the notebook here. Let's just try this again. We'll just
So
open
you
it up.
can, down below, you can click on one,
I
or
Yeah.
maybe you can't.
don't think you can. Oh, sorry. I got that. Hang on. So we can just kind of look at what was involved in it. Oh, good. It kept my results when I hit replay. That's good. So, yeah, the short story is that doctors weren't washing their hands, and this guy here with the hard to pronounce name started to see something was up and inferred some things and statistically showed them they should wash their hands and eventually convinced some of them to do it. Is that the gist of it?
Insert
Yeah,
joke here about
amazing
Americans
is-
in 2020 not washing their hands.
Yeah.
Well, I would say I used to, right when COVID first came out, and
say what was amazing about it, we chose this prior to COVID.
yes, when COVID first kind of came out and it looked like Italy was burning, I noticed that there was always a line to wash your hands in men's rooms because we didn't go to shelter in place quite yet. But now I don't know what happened in our joint American experience, but somehow we collectively got the idea that COVID is over. And now if I find myself in a public bathroom, I'm back to being in the 10% of males that wash their hands, you know. I was like, it never really made sense why there would be 15 urinals in a bathroom at an airport and only 4 sinks, right? And then when there was a line, I was like, people are going to have to fundamentally rethink the bathroom because we need to have a lot more sinks. People are coming in here just to wash their hands. They don't have to go to the bathroom. They just want to wash their hands. And then now we're back to normal where everyone's going to the bathroom and nobody's washing their hands again. And I'm like, this whole experience has really made me think that maybe I'm developing a permanent case of agoraphobia. Like maybe I'm just hyper aware that people aren't very clean and that we go to these events where we're all touching each other. So luckily the R naught scores for our common diseases are not very high, but we're not super smart at learning about pandemics. Like we're going to repeat all these mistakes again. I feel like, but anyway, sorry. Keep going, Dustin.
All right, so we start by
else?
just reading in a data frame. We did that in probably the first week, and maybe I hadn't done it for a little bit. And then we break that yearly data. So by the way, the data looks about like this, pretty simple. We have our years, births and deaths. And then we add this proportion of deaths that we use the rest of the project. So deaths divided by births. Break it into clinic 1 and clinic 2 to kind of look for differences in the proportion. For whatever reason, we
This
print
was
one of
specifically
them.
deaths in childbirth, right?
Yes.
Yeah.
After childbirth. And by the way, there was another thing which worried the doctor very much. Midwives didn't have such high rate of
Right.
dying.
Right.
I didn't do this exercise, but remember from my history, it's because midwives would do one delivery, whereas doctors would go from one patient to the next. And so that's how they were bringing germs from
Yes,
one mom to the next delivery they did.
and in
So-
particular, they would go to morgue.
Yeah. So
They would
it'll
go to
show that
morgue, yeah.
we'll skip ahead here to kind of get to what you're saying. So the midwives only tended to women giving birth versus medical students that spent time in autopsy rooms examining corpses.
Yes.
And it just shows about ego, right? Like I couldn't possibly be killing these women, right? It's not me killing them. It's something
Yeah.
else.
Okay, so brief overview then, in case there's more to chat about with this exercise. So break it into 2 groups of yearly. It shows us this not very intuitive way to plot 2 things together using the pandas plotting, data frame plotting. And so that's a handy thing to know if you're going to do EDA with multiple data frames in pandas. And
Can
you can
you
see that
show
one's
that?
higher than the other, right? That's kind of the gist of it.
Can you show the 2 different lines there? You have
So we
yearly
have the
plot and then
first,
you have yearly 2-dot plot. But how are those connected to each other?
so we actually set yearly 1-dot plot to be AX instead of just like saying, instead of just typing it. And then we do yearly 2-dot plot. We pass in the AX object as the argument. And then at that point, for some reason, when we call ax.setYLabel, it happens to everything.
Okay, but
So
that graph is built off of the yearly 2 plot. It's just that the yearly 1 plot was given into it. Is that right?
that's my understanding of it. I didn't bother checking how it actually works, but that seems to be the case. Yeah, you build one up, save it as a variable, and then pass it into the other one.
Okay, cool.
So I think if you weren't doing pandas, you would do fig comma ax equals, and then it would be, plt dot whatever plot, right? And so then you would just continue to build on it. Because pandas is this shortcut into matplotlib, then you normally don't explicitly deal with fig and ax. And so this extra parameter at the end where you can pass in the ax if you want to do new layers on an existing figure, that's how you jam it in there.
That makes sense.
So instead of, right, because normally you do ax.plot, but in this case, the object has to be your data frame because it's data frame.plot. So then you need some other way to know what existing plot are you adding to, so you jam it in as an extra parameter.
Yeah, so I think this was probably the first time where I was like, I don't know if I like this panda. Like I was fine with the pandas plot. I know it's just wrapping other things. At this point, I was thinking maybe I just want to go back to the plotting libraries and pass the data frames in rather than do this. But I haven't really done a lot of EDA in Python, just courses like this, and then I forget about them and go back to using Tableau or Excel or whatever.
If I dare make the analogy, for me, this is like the lambdas. If you're just going to do a real quick histogram of one column in a pandas frame, go ahead and do that. When it's multiple lines like this, you might as well just do it the matplotlib formal way.
That's a good analogy. Way to make the conversation turn around on us. Come full circle. Okay, so now we start hand washing.
So now they start washing hands. We want to break out. So we start to look at it at a monthly level so we can see the change basically is the setup here. Proportion of deaths. We've got everything by monthly, so we're just using the start date of the month. There's a handy little parameter you can pass to parse dates, and you give it your date fields and it'll treat those as dates as it comes into the data frame. Now we start to see sort of what it looked like over time, and basically saying, can you see that there's a drop off right around here due to hand washing? I'm sure we all see that. After that, we split it out into before and after. And so we're doing, if you remember pandas filtering, we're able to do some less than and greater than equals to filtering. We again plot multiple things together in the same way, just a few more labels and things that were added. And this time, because there's not an overlap in time frames, it just kind of has this interesting transition to after washing. So anyone not convinced to wash their hands yet? Are we all on board?
I think this only applies to doctors, really.
I knew that's what you were going If I go to a morgue, then I will wash my hands. I'm sure that's what some of them did too. They were like, okay, after the morgue, that's the time we'll do it.
Well, what is amazing from COVID is COVID actually did teach me to wash my hands because of all the different ways they showed that soap breaks down protective proteins around viruses. And soap is just an amazing deterrent for all viruses. Their little protein shells get completely destroyed and you just kill it immediately. And I'm like, well, we don't need fancy alcohol wipes or we don't need Purell. We don't need any of that. We just need regular soap, and we need to wash our hands and not touch our faces. And if we do that and we cover our mouths and stay 6 feet apart, you really do statistically really lower the chance of both contracting and spreading something.
Well, it's
really
also
severely.
amazing, my observations of how many adults will just sneeze into the air or their hands. And it's like, come on, we teach kids not to sneeze into the air or their hands.
Yeah, like you really do just need to use your elbow. And yeah, I will admit that I thought I was washing my hands a lot pre-COVID, but now like when I come into my house, it's almost reflexive. I just go right to the sink and wash my hands. If I'm thinking that I haven't washed my hands lately, I go wash my hands. And I'm curious to see what a post-COVID flu season looks like. I bet we have much more mild flu seasons now forever because of this. We've trained more people on the importance of hand washing and not standing so close to sick people. And we've told employers that there's not a badge of honor to have your employees come in sick. In fact, it's a danger to your entire business. And before, I heard many, many times people are like, oh, just work while you're sick, you know. But now we've shown employers, oh, that's a really good way of wiping out your entire workforce. Like,
I agree with all your points, but I'll take your bet on things getting better a few years down the road.
Like you said yourself, you've seen people regress to not hand washing.
yeah, I have. But I think what percentage where people are continually hand washing is enough to make a difference. Like it's not 50%. I bet if only 10 or 20% of people now more frequently wash their hands, it can make a big impact on a virus spreading.
I like your optimism.
Thanks.
I just plan to wear a face mask forever, so I think that'll help me.
I still wear gloves.
I think the face mask is going to be like socks, where like you go to Costco and you just pick up a 10-pack of face masks because the washing machine like shreds them, and you know, I think now it's just going to be a regular clothing item people just buy, right? You know, can you buy me a new face mask? Mine are wearing out. You know, you're just going to have those all the time.
I'm on board with the hand washing, but the face masks suck.
Well, you don't like your face mask tan?
No.
Well, it's very inconvenient to when you ride a bike.
Well, in a bike, it's not important to wear a face mask because people don't like to get close to you when you're speeding on your bike. They don't try to get close. But if you are going to the
Yes, but
grocery store
once
or
in a
something,
while, you get close to something.
yeah.
And it is not a good moment to stop and to get on the mask.
Okay, so what's the next exercise, Dustin?
Then we do a bootstrap analysis, which in order to understand what this was, I had to go into Statistical Thinking Chapter 2.
Yep.
They kind of describe it pretty simply, but you're basically doing a simulation. And I think you're taking a sample of real values and doing a lot of simulations of that. And so we're doing samples, taking the means, doing the difference of means, and then doing another experiment is the word I'll use, and building out a confidence interval with that. If anyone wants to clarify all that, please feel free. And then all we did is print out what the 0.025 percentile or the 2.5 percentile and the 97.5 percentile is. I guess we didn't call out, there it is, an 8 percentage point drop once they started washing hands. That's a pretty big drop.
So yeah, we didn't do the second statistical one. The thing about the bootstrap, and Maya, feel free to jump in at any point, is that it's a very useful technique when you have an unknown distribution. And so from a single sample, it's not 100%, but from a single sample, you can, by bootstrapping, you can oftentimes use statistics of the bootstraps as a proxy for statistics of the original unknown distribution. Does that make sense? Did that make any sense at all, or did I say that badly?
So what I'm understanding
No,
is
it
you
makes
don't
sense,
have
yes.
you don't have
Yes.
enough. I'm getting it. You don't have enough. Enough elements to get a full distribution view, but by taking those and basically, yeah, bootstrapping with those, simulating data with those, you can get to a fairly accurate view.
So if you wanted to know what's the 95th percentile of the actual distribution of deaths, you don't have that. What you do have is you have X many data points, and calculating the 95th percentile on the bootstrap is better than just trying to look at the 95th percentile of your however many 3,000 data points.
Yeah, that was a good, I like that description. That helps me.
Yes. And the bootstrap will work for more complicated statistics, not just something simple like a median or a mean or whatever.
Well, we may not have a mean, but the usual constants interval relies on the large number theorem. And assumption there is that mean should exist, and it might not exist for some distributions. So yeah, if we don't know much about distribution, then bootstrapping is good from one side. From another side, if you have very, very, very many points where a lot of data, bootstrapping works slowly. I just tried it. And well, it could be way too intensive.
Yeah. So if you have like a machine learning problem you're working on, you have some training set data just like this, you could just train the model based on the data that you have. And I guess Maya's right. It could be very labor intensive or compute intensive. But if instead you bootstrapped different samples of your training data and repeated your model building, then that would give you a level of information beyond just simply training your model once on the full data set.
Cool.
That was super clear and helpful. Thanks, guys.
Yes, thank you.
Quick happy note to end on is that because there was not a lot of statistical arguments and statistics in use, basically he was ridiculed and the discovery was rejected and he was forced to leave the hospital. But now we understand that he did something really helpful. That's how it ends for us.
Well, we really don't, you know, I've seen the meme many times where they're like, every single time a disaster is imminent and there's some scientist saying what to do and everybody ignores them. I always think those movies are so silly. But now I realize that the movies are understating the
Yeah, it also reminds me of, Ike, you may know, Atul Gawande wrote a book, I don't know, half a dozen years ago. I forget the exact title, but basically it was why doctors should use checklists. It's like pilots use checklists, like everybody uses a checklist to do their job, and doctors are like, I'm a surgeon. I don't need a checklist to remind me when I do a surgery. And like, as far as I can tell, the doctors all blew him off even after he wrote his book.
Yeah. Well, my household's a little biased because my wife has, she works in public health. And so her main job is to teach doctors how to have better outcomes. Because a lot of health is not medical, a lot of health is programmatic. Like if I know what zip code you live in, I could probably predict pretty accurately your longevity, you know, your education background, your income level. So there's obviously, why do people who live here and behave this way have a much different health outcome than people who live here and behave this way, right? And so she teaches doctors, you know, hey, you need to identify who your patient is before you just forklift a resolution for them. You need to understand what their lifestyle is and have difficult conversations about that lifestyle. Or you're not going to have the outcomes you want to have. So hers relates specifically to HIV, right? Which is, just because the patient is telling you this doesn't mean that that's true. If you know more about where they come from, you will know more about their tendency to have HIV or not, and how they got it. And then she does a lot of prevention, right? Which doctors aren't really in the business of prevention, right? Doctors are very micro. You have this problem, let's fix that problem. But you know, public health is really interested in how to keep a large body of people from getting something in the first place, right? It's much cheaper if you can stop them from getting something in the first place. But so anyway, I hear her conversations with medical professionals all the time. She has to be very, very respectful, but tell them this old way you were doing something isn't going to help you next year. You need to do something better. But so she's used to getting ignored. I don't think doctor egos have changed all that much.
Well, that's a wrap.
So are you guys excited? Next meeting is going to be a lot more machine learning, advanced analytics. I think that machine learning and advanced analytics is easier than stats. So, because I think you don't necessarily need to understand what the algorithms are doing to understand how it got to its results and why the results are important.
We'll see if they make us hand code any of these algorithms like they did a few here.
Yeah.
Hopefully not.
Hopefully not. All right, thanks guys. I'll put this online. I appreciate you guys being here. It's always great when we all participate. All right. See you next
Thanks, everyone.
month.
Have a good night.
Yep.
All right, good seeing you
Thanks,
guys. Stay
Dustin.
safe.
Yep, bye,
All right,
Scott.
take care, everyone.
Thanks, Ipsy.